In the previous section, we described the various stages of compilation. By the end of this module, you'll be able to describe various considerations when compiling an FPGA VI. In this slide, we see a couple of FPGA compilation considerations. So we'll talk about each of these bullets in the coming slides. So let's talk about what causes a recompile. So when you run an FPGA VI that LabVIEW has already compiled, LabVIEW does not need to recompile if the VI does not have any non-cosmetic changes. So if I have a LabVIEW FPGA VI and I've compiled it already and I haven't made any changes to it, if I hit run, it'll go ahead and execute the compiled FPGA VI and it won't have to recompile it. Also, if I make a change that is just cosmetic, so for example, if I was to rearrange the front panel and all I did was move my controls and indicators around, and that's all I did, if I hit run again, because I haven't made any actual logic changes to it, that VI is not going to have to do another recompile. However, if the LabVIEW FPGA does have a non-cosmetic change, then LabVIEW is going to recompile the VI on the next run. So for example, if I change something on the block diagram, like if I change an algorithm, then next time, if I save it, next time I run it, it's going to have to recompile because something has changed. Also, if I add or delete functions on the block diagram, or if I rename a controller indicator, because that name changes, it's going to have to change the way that it sends it over the bus and associate it with a different name. So in that case, I'll have to do a recompile next time I run that VI as well. Or if I add a new control or add a new indicator and I save the VI, then when I hit run, it's going to have to recompile the VI. Okay, this slide is talking about how to compile an FPGA VI remotely. So by default, when you install LabVIEW FPGA and you're compiling your VIs, LabVIEW FPGA, the compile server, and the compile worker all reside on the same computer. However, if you want to make things more efficient, sometimes what people will do is they will install the compile server and the compile worker on a remote computer. And maybe that remote computer has a lot of resources. It'll be able to compile things faster. So this way, they don't use the resources on their development computer, and what happens there is when I hit run, it'll send our compilation to a remote computer to handle the actual process of compiling it, and that way you save some of the resources on your own development computer. So if you want more details on the exact steps for that, you can go to the Compiling an FPGA VI Remotely help topic in the LabVIEW help. Other things you can look into is there's also something called the LabVIEW FPGA Compile Farm Toolkit. And if you're using this, what that'll do is you can have multiple developers send compilations to a compile server, and that compile server machine will handle sending all the different compiles to multiple computers that all have compile workers on them. So in that case, because there's multiple computers that are handling the compile, you can have multiple compilations going on in parallel, which will save a lot of time. So if you want to create a farm system for compiling your FPGA VIs with multiple developers, that's another route to go as well. Another thing you may want to look into is the LabVIEW FPGA Compile Cloud Service. This is a way of offloading your FPGA compilations to a high-performance, high-reliability cloud server to reduce the compile time of your LabVIEW FPGA VIs. So those are just some options you have for compiling your FPGA elsewhere besides your development computer. Here we describe the two causes of a compilation failure. So one would be timing. So for example, if your FPGA VI is asking for some timing, maybe you're asking for a loop rate that is higher than what your FPGA can implement. In that case, the delays in the design circuit exceed the period of the specified clock, and your FPGA compile will fail because it couldn't meet the timing requirements. Another reason your compilation might fail is resource utilization. So in this case, your design requires more FPGA resources than are available on the FPGA. So the way you've written your FPGA VI, the FPGA itself did not have enough resources on it to implement your design. So when your compile fails, those are the two things that you would have to go back into your FPGA VI and try to fix. And we'll talk about ways of fixing timing and also trying to make your FPGA VI more efficient on resource utilization in the rest of this course. On this slide, we see some of the Xilinx compiler options. So the way that you get to this window is you would go to your build specification, and then you can right-click it, and then go to its properties. So if we take a look at this window here, what you should usually have enabled, which is enabled by default, is that use recommended settings item there. So when that is enabled, what Xilinx will do is it'll use recommended settings based on whatever target you're setting your FPGA compile for. So this is the recommended item to select, so I would usually just go ahead and just use the recommended settings. However, there's other design strategies you can use if you want. So if for some reason you need to use one of these different design strategies, you can disable the use recommended settings item and then choose one of these. So some other design strategies that are available to you are minimum compile time, or you can try to make the compile try to optimize the timing performance. So if you're failing your timing and things are getting really close, you can try to optimize for timing. And you can also try to optimize for area as well. There are other custom things that you can do as well on this window, but in general, you should just use the recommended settings. Now you can describe various considerations when compiling an FPGA VI. Next, we will describe basic optimizations you should implement as basic programming practices for all FPGA VIs.